Hello viewers, welcome to my channel. My name is Saurav Sharma, and in this video we are going to discuss the end semester solution of end semester exam of numerical analysis and design subject. So these questions have appeared in 2023. So let's get started. So here our first question is, find the root of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equation and show these nature whether they are convergent or divergent in nature. So first we will assume that fx is equals to x square minus x square minus x minus 1, and the value of a function at 1 and 2 is negative and positive respectively. Hence we can conclude that the root is between x is equals to 1 and x is equals to 2 point. So we can take x0 is equals to 1.5 as a median value. Now let the function fx is equals to x square minus x minus 1, and here the following equation gx that can be made through fx is given here. So these are gx is a function which is expressed in the form of x. So here you can see that this fx function can be represented in form of x in following ways, and then in this column we have take the derivative of gx, and then we have put value of 1 and 2 in the derivative of gx. So here you can see that which value is less than 1 and greater than 1 respectively. So for the selection of correct gx, what we do is that the resultant of value of derivative of gx should be less than 1, and if multiple value of gx are less than 1, then we will choose the least one. Yeah, we will choose the value which has least 1. So here you can see that this gx function the derivative, so the value of 1 and 2, when we put the value 1 and 2 in the derivative of gx, both values are negative, I mean less than 1. So this is convergent. While if you see on the other function, the value is here is greater than 1, it is greater than equals to 1, and and it does not satisfy the criteria which says that gx should be less than 1. And here in this gx function case, we can see that both the values are less than 1, thus it is satisfy the following criteria, so we can select it as the correct gx. So now what we will do is that we will assign gx is equals to under root x plus 1. So we will take and for the fixed point iteration method. Now as we know, as we have already mentioned that x0 is equals to 1.5. Now we will find the value of x1 by putting value of x0 in this gx function. So we will get the value of x1 as 1.5811. Now for finding the value of x2, what we will do is that we will put the value of x1 which is 1.5881 in this gx function, and then we will get the value of x2. And similarly for finding value of x3, we will put value of x2 in this gx function. So this will be continued. Now as you can see that the error between x7 and x6, which are given here as 1.6179 and 1.618001 respectively, is the error between x7 and x6 is 0.000101. Hence the root of the function is 1.618001. So now let's head to the our next question. So here write on algorithm for finding the root of function using fixed point iterative method. So in this question we have to write algorithm for finding root of function. So what we will do is that first we will read x0. Now we will read e, which is a tolerable value to determine the desired level of accuracy. Now we will initialize iterative counter I is equals to 0. Then we will repeat the following step until the absolute difference of x1 and x0 is less than e, which is a tolerable value, or I is equals to n. So inside this, what step will be repeated? So these are the three steps which will be repeated until we will get the absolute difference of x1 and x0 is less than 0, sorry, less than e. So we will increment value of I, then we will calculate the next approximation using the formula x1 is equals to value of function gx at x0, and when gx is a suitable function that transform fx into the form x is equals to gx. Update x0 as x0 is equals to 1. This is the next step. Now if the absolute difference of x1 and x0 is greater than e after the maximum number of iterations, then we will print the method and may have failed to converge, and we will return the final approximation x1 as the approximate root of the equation. So now let's head to the next question. In this question, it's given that find the solution of the system of equation using iterative method. So these are the given equation, simultaneous equation. Now we will find the value of a, b, c in respective equation by taking variables from one side. So yeah, for finding value of a, we will move everything on the right hand side. So you can see that a can be represented as this by equation 1, and by equation 2 b can be represented as this, and by equation 3 c can be represented as this. Now what we will do is that we will consider a0 is equals to 0, b0 equals to 0, and c0 is equals to 0. Now for finding the value of a1, we will put v0 and c0 in the formula of a, and thus we will get the value of a1. Now for finding value of b1, we will put a0 is equals to 0 and c0 is equals to 0 in the formula, thus we will get the value of b1. And for finding the c1, we will put the value of a and b as 0, so we will get the value of c1. Now for finding value of a2, we will put to v1 and c1 in the formula, so we will get value of a2. For finding the value of b2, we will put value of a1 and c1, and now for finding c2, we will put the value of a1 and b1, so we will get c2. Now as we have got the value of a2, b2, c2, now similarly we will do this method for finding value of a3, b3 and c3. So we will follow this step till we get repeated approximation. So that's how this method works. Now in the next question, we have to list out 4 disadvantages of Gauss elimination and 3 advantages of iterative method over the elimination method. So the iterative method is superior to elimination method due to, so first point is computational effort is approximately 2n square arithmetic operation per iteration, and if convergence is achieved in less than n iteration, it is significantly superior compared to the elimination method. Second point is another important advantage of iterative method is small rounding errors. The rounding errors being the one committed in the last iteration. Thus, for ill-conditioned system, an iterative method is a good choice. Now, in Gauss-Seidel method, we set xi equals to newly calculated value of the iterative stored in temp. Now, what are the disadvantages of Gauss elimination? So here are they are given as follow. So the computational effort is approximately 2n cube divided by 3 arithmetic operation in each of elimination step. The amount of bookkeeping necessary is considerable. The rounding errors may become quite large, particularly for ill-conditioned equation, and any special structure in the matrix of coefficient is difficult to preserve during the elimination. Now in the next question, we will have to write the algorithm for Lagrange inverse interpolation. For this, we will write the input. We will read number of input n, then we will read the value of x, and then we will use a for loop for I is equals to 0 to I is equals to n minus 1, and inside this for loop we will read xi and yi value. Now we will assign sum is equals to 0. Now we will again use a for loop for I is equals to 0 to I is equals to 1. Now what we will do is that we will set product is equals to 1. Now for I is equals to 0, then inside this for loop we will again using a for loop for I is equal j is equals to 0 to j is equals to n minus 1, and inside this we will put a if is a conditional statement where if I is not equals to j, then we will assign the value product this we will assign product variable this computed value, and similarly for we will assign the summation of sum and the product of product and xi to the sum value, and then we will print the sum. So that's the algorithm for Lagrange inverse interpolation. Now in the next question we have to evaluate integration of 1 divided by 1 plus x square in range 0 1 using 3-point Gauss quadrature formula for the given abscissa and weight. So here t1 value of t1, t2 and t3 are given, and w1, w2 and w3 are also given. So now we will consider that a is equals to 0 and b is equals to 0. Now we will find the value of x1 by using a value of a and b. Now putting the value of a and b, we will get x is equals to 1 plus t divided by 2, and after differentiating both sides we will get dx is equals to dt divided by 2. So now in the following step we will substitute the value x and dx in the fx by t and dt. So we will get ft is equals to integration 1 to minus 1 uh, 1 to minus 1 where and 2 divided by 4 plus 1 t 2 dt. So now by putting the value of t, we will get the resultant as 0.78527. So this is the integrated value of fx from the range 0 to 1. Now in the next question we have to write down algorithm for the Widal rule for the 6-point. So it's quite simple, like you have to read start, then you have to read and, then we will assign the subtraction of n minus start divided by 6 to the h variable. Now we will use a for loop from I is equals to 0 to I is equals to 6, and then we will read by I. Now we will set the value as we will assign value of as the value 0.3 into h and different values of y. Now we will print this value of s, which will be the resultant integration of Widal rule. So this is the algorithm of it. Now in the next question we have to write the algorithm for Runge-Kutta fourth order expression. So we will define a function which take two argument x and y and return the expression. Now we will read starting, ending and split. Now we will assign h variable the subtraction of ending minus starting and divide by split. Now we will use a while loop which has a condition which state as starting should be less than equals to ending. Now we will compute value of k1, k2, k3 and k4 respectively by using h and function, and then we will increment value of x by adding h, and similarly we will increment value of starting by adding h, and then we will compute value of y with the help of computed value of k and adding that with y0, and then we will print the value of x and y. So this is the algorithm for Runge-Kutta method. And now in the next question we have to apply predictor corrector method to solve dy by dx is equals to minus xy, while where value of y at 0 is equals to 1 in each step of 0.1 up to y 0.2. So First we will we can compute value of ypn plus 2 and ycn plus 2 by this expression. Now we will calculate value of k1 and k2 using function using function fx, using the value of function at xi yi and xi plus h by 2 and yi plus k1 h by 2, and then we can calculate the average value k by using k1 and k2. Now we can also find yi plus 1 by using this expression, where we can find the value of I plus 1 by adding yi plus product of k and h. Hence y01 is equals to 0.9975. So now we will find the value of y at 0.2. So we will use that previous expression to find the value of y02, and then we can again, so we can apply, here you can see that the value of y point at 0.2 is 0.98005, and here we have again used that same formula, and we will get the answer as 0.982712. So we can apply corrector formula again for more accurate value by putting this corrector value as predicted value in the corrector formula. So that's how we have ended all the we have solved all the questions here. So thank you for watching this video. See you next time.